Now with the help of the molecular model, now in the how the pi and the pi conjugation, it is showing the delocalization. Now we'll see. Now it is perpendicular to each other. Now what I said, if the two pi bonds are parallel to each other, then only the delocalization will be happened. But here you can see, here one is in this manner and one is here. These two are the perpendicular to each other, right? When these two are the perpendicular to each other, how it will show the delocalization? So that's the reason in the alene molecule there is no any delocalization. So carbon and this carbon pi bond is parallel to each other. That's the reason this oxygen has been delocalized here and this pi bond has been shifted. Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. In our GOC already we have did the two lectures, right? One is what? How the electrophiles and how the nucleophiles and what are the ambident nucleophiles, how the bonds are breaking and what are the reactive intermediates, carbocation, carbanion, free radicals and the carbons, that all we have studied. Now and in the lecture number 2 we have studied about the electron displacements in the covalent bond, that is inductive effect. How inductive effect is application of the inductive effect, how we have to apply to the reactive intermediates, already we have seen in the lecture number 1. Now in this lecture number 2, the very important application and very important concept that we are going to study, that is a mesomeric effect. Clear? Now this mesomeric effect concept applications will play very crucial role in our entire organic chemistry. Clear? I will explain very clearly. Now try to listen the class from the starting to ending. Clear? Now if you skip any of the concept also, now it may be make you or it may get a problem for you in the application part or while you are solving the questions. Clear? Now let's start our lecture. Before going to the lecture, first we have to study about the which one? Resonance. First we have to study about the resonance. Sir, what is the meaning of the resonance? And this term resonance we are going to see in our entire organic chemistry, or we are going to use in our entire organic chemistry. First, the resonance is nothing but complete transfer of pi electrons is known as the resonance, or delocalization of pi electrons is known as the resonance. Clear? Now the term resonance, if I use that, at the same time you should get in your mind that resonance is nothing but complete transfer of the pi electrons or delocalization of the pi electrons. See, now what is the meaning of the resonance and why we are going to study? See, for one molecule it may exist in the 2 or 3 Lewis structures. For a molecule, one or it is having the 2 or more Lewis structures. With a single Lewis structure, we cannot explain its property. Sir, what is the meaning of the its complete Lewis structure? Now, here one Lewis structure I was taken. Clear? Now, in this Lewis structure, it will be exist in the which one? It will be exist in the another form also. It will be exist in the another form also. In this manner, it will be exist. Clear? Done? Now before the oxygen is present in, let's suppose this is the oxygen number 1. Now this is the oxygen number 2. Now this is the oxygen number 1 and this is the oxygen number 2. Before the negative charge is on oxygen number 1 and now the negative charge is on the oxygen number 2. These two we call it as a canonical structure. Canonical structures. Now, these structures are not having any real existence. This structure is not having any real existence. In between these two structures, we are having the one original structure that we call it as a resonance hybrid. That we call it as a which one? Resonance hybrid. Clear? Now, this resonance hybrid is only having the real existence. These two structures are called as a canonical structures. Sir, how they have identified, sir? This resonance hybrid is only having the real existence. Why not these two are having the real existence? Now, how they have found means, when these structures, when the canonical structures they have given, they have found that first this carbon and this double bond O, this carbon and the double bond O, bond length is 1.21 angstrom they have seen. Done. And this carbon and this single bond O minus, this carbon and this single bond O minus, they have found that this bond length is 1.30 angstroms, 1.30 angstroms. But experimentally, when they have seen the exact resonance hybrid, they got that this carbon double bond O and this carbon and this oxygen negative charge complete bond length they have found that it is having the 1.28 angstroms, 1.28 angstroms. Clear? By that they are saying that whatever the resonating structures we are seeing, those are hypothetical, Clear? Now in between these two resonating structure, one actual structure will be there. That structure we call it as a resonance hybrid. Clear? Now next well-known example I will explain for you, that is a benzene. Now the benzene we are seeing for the benzene, the resonating structure of the benzene we are going to see in this manner. Now this is a resonating structure of the benzene. How, sir? Now in between the 1 and 2 carbon, this is 3 4 and this is the 5 and 6. In between 1 and 2 we are having the double bond, but here we are having the only sigma bond. Clear? Now these are the resonating structure. In between these two resonating structure, we are having the one actual resonating hybrid, the resonance hybrid. That resonant hybrid will be in this manner. This resonant hybrid in this manner, right? Now this indicates that, that's the reason only whenever we are representing the benzene, we used to represent in this manner, right? This indicates that this pi bonds in the benzene is completely delocalizing in the ring. Clear? Done. Now how they got to know that the resonance hybrid? First, when they have seen this 1 and 2 carbon, this carbon and this carbon double bond, they have found that it is having the bond length of 1.34 angstrom. Now this 2 carbon and 3 carbon sigma bond, right? This carbon and this carbon sigma bond, they have found that it is having the 1.54 angstrom. But experimentally, when they have seen this complete carbon and this carbon and this complete carbon and this carbon bond length, complete this circle bond length, they have found that it is having the 1.38 angstrom. 1.38 angstrom is the bond length they have found. By that it is saying that, now what is the meaning of the resonance? Now resonance is nothing but molecule having two or more resonating structures. Resonating structures, RS, resonating structures. Don't R. Canonical forms. Resonating structures and canonical forms are not having real existence. They will not having real existence. Clear? Now which is real existence? Resonance hybrid is real. Resonance hybrid is a real. Clear? Next very key point you have to remember, that resonating structure is having higher energy than the resonating structure is having the higher energy than the resonance hybrid. Clear? Resonating having the higher energy than the resonance hybrid means, now in the next very key point you have to remember, Now what is the key point you have to remember? Here in the resonating structure, now molecule in the resonating structure it should have, or in the resonating structure it should have equal paired or unpaired electrons in different contributions, in different contributions. Clear? Is that, sir? Now with the example I will explain. Now listen carefully. Now I was taking the one well-known example for you, that is a which one? 1,3 butadiene. 1,3 butadiene. Here now this 1,3 butadiene. Now this pi bond of the electron has been shifted toward this carbon. Then its a resonating structure will be, now here is the negative charge, here is the hydrogen, and here it is a hydrogen. Now here this carbon, and the carbon it is having the positive charge, here is a hydrogen. Now clear? Now here the bond. Now here it is a hydrogen, and here it is a double bond, and here it is a hydrogen, and here it is a hydrogen. Clear? Now here in this, now count the electrons. It should having the equal electrons or not. Now we'll count. Here one bond contain 2 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Here total electrons we are having the how many? 22 electrons we are having in the which one? 1,3 butadiene. When it has participated in the resonance, whether it is having the 22 electrons or not, now we'll see. Now here the negative charge indicates that 2 electrons. Clear? Blindly believe this. Negative charge indicates that 2 electrons. Now here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Clear? Both are having the equal electrons, right? Both are having the equal electrons. Clear? Now these are known as the resonating structures. Next very key point you have to remember that now in the resonance, only electrons will move, not the atom. This is a one very key point you have to remember. Any compound, if it is showing the resonance, in the resonance only the electron will move, not the atom. Done? Now here the example for you, if you take the general example, CH3 C double bond O and H. Done? Now here the resonance, here the lone pair of electron, and this pi bond, it is pi electrons. This pi electrons are moving towards the oxygen. Then these two are the which one? These two are the resonance. These two are resonating structures. Here only the which one is moving? Only the electrons are moving. Done? But if suppose if they have given this one. Now this is a aldehyde. Here in this aldehyde, here this sigma bond pair of electron has been moved here. Now this pi bond, if it has moved to this oxygen will get the negative charge, and this proton positive charge, it will go and attack here, and this one we will get CH2 double bond COH, and this is a H. Now this is not the which one? This is not the resonance. This we call it as a tautomerism. Why? Because here the atom has been moved. From the, if you take this as a 1, 2 and 3. Now in the 3 position, whatever the hydrogen which is present in the 1 position, that it has been moved to the 3rd position, right? So this is not the resonance. This we call it as a which one? Tautomerism. Here in the any compound to show the resonance, only the electrons should be moved, not the atoms. Not the atoms. Done? Now we'll see the rules for the stability of the resonating structure. If suppose two or more resonating structures if they have given, then what are the rules? What are the rules we have to follow to find which resonating structure is more stable among them? Now we have to see. First, here the first key point. Rules for stability of resonating structures. So many of the students, they will get confusion or they will make the mistake in this only. So one or two or three more resonating structure they will give you, and they will ask among these four resonating structure, which resonating structure is a more stable, they will ask. In the first key point you have to remember, more the number of pi bonds, clear, more the number of pi electrons, or more the number of pi bonds or pi electrons or pi bonds in a resonating structure is more stable or more greater than less number of pi electrons containing in a resonating structure. Okay, more the number of pi electrons or bonds that contain in the resonating structure is greater than less number of pi electrons or bond that containing in the resonating structure. This is the first key point. More the pi electrons, more will be the stability. Second point you have to remember that octet completed resonating structure is greater than incomplete octet resonating structure. Sir, what is the meaning of the octet complete resonating structure and what is the meaning of the incomplete resonating structure? Now, octet complete resonating structure means, here see, double bond O and oxygen, it is having the positive charge. Clear? Now you see, here the carbon octet completed and the oxygen octet has been completed. How? Any compound to complete its octet, it requires 8 electrons, right, among them. Now here oxygen, it is having the 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, and the carbon is also having the 1, 2, 3, 4, 5, 6, here 7, and here it is a 8. Now here the octet completing resonating structure, this resonating structure is greater than incomplete resonating structure. What is the incomplete resonating structure? Now this is a incomplete resonating structure. Now this is a incomplete resonating structure. Now how the incomplete resonating structure, sir? Now you can see oxygen octet has been completed. 2 lone pairs, 4 electrons, and here it is a 5, 6, 7, 8. But carbon octet has been not completed. How? Now you can see here 1, 2, 3, 4, 5, and this is 6. This is an incomplete resonating structure. Done? Now third point, neutral resonating structure is greater than charged resonating structure. Sir, what is the meaning of the neutral resonating structure and what is the meaning of the charged resonating structure, sir? Neutral resonating structure means if you take the formic acid, now this formic acid is a neutral. Now charged resonating structure means if this electron, if it has been delocalized, now this is a charged, right? Now this is a which one? Charged resonating structure. Neutral resonating structure is, or neutral structure is more stable than the charged resonating structure. Done? Next one, fourth one. Now negative charge on more electronegative atom. Negative charge on more electronegative atom is more stable, or the resonating structure, it is having negative charge on the which one? More electronegative atom, it is more stable than the which one? Than the less electronegative atom bearing the which one? Negative charge. Now here one carbon and the oxygen, it is having the negative charge, and the carbon it is having the positive charge. This is more stable than the oxygen bearing the positive charge and the carbon bearing the negative charge. Clear? Now this resonating structure is more stable than the more electronegative atom bearing the negative charge is more stable than the less electronegative atom bearing the negative charge. Clear? Next point you have to remember, that is opposite charge. Opposite charge nearer. Clear? Opposite charges in the resonating structure, opposite charges should be nearer. Opposite charges nearer resonating structure is more stable. See, what is the opposite charges resonating structures? If you take CH2 double bond CH2. Clear? Now here if this has been resonated here, now what we will get? Here the CH2 negative and CH2 positive, and here the CH double bond, and it is a CH2. Clear? Now this structure is more stable than which one? CH2 positive charge, and here the bond CH double bond CH and CH2 negative. Compared to the this resonating structure, now this one is less because opposite charges are far away from them. Here the opposite charges are nearer to them. Clear? Done. Now we'll do some questions based on this concept. Now based on this concept, now we'll do some questions. Clear? Now, first question, if suppose if they have given CH2 minus and C double bond O H, and the second resonating structure they have given CH C H and O negative. Clear? Now among those two, which is the more stable resonating structure among the 1 and 2? Now 2 is more stable resonating structure, right? Why? Reason. Clear? Now why the reason? Here you can see, here the carbon double bond O. Now here the what? More the number of double bonds should be present in the what? More the number of double bonds should be present in the resonating structure. First key point. Then after that, more electronegative atom bearing the negative charge. Means more pi bonds and more electronegative atom having negative charge. Due to that one, resonating number 2 is greater than the 1. Clear? Now, second, let's suppose if one resonating structure if they have given in this manner, one double bond O minus and R O minus, and it is double bond O. Now among the 1 and 2, which is having the higher resonating structure, or among those two which is having the higher resonating? In this case, both are having the equal resonating structures. Why? Because now you can see here oxygen is bearing the negative charge, and oxygen, carbon and the oxygen we are having the double bond. Here also oxygen is having the negative charge, and the carbon and the double bond O, it is having the, and the carbon and the double bond O. Clear? Same number of pi bonds, and the more electronegative atoms are bearing the negative charge. In both the cases, both are stable because both are having the equal resonating structure. Done. Now we'll see the another example. In this another example, one they have given C double bond O minus, and the another one they have given RC double bond O H. Among the 1 and 2, which is more stable resonating structure? 2 is a more stable resonating structure. Why? Because reason 2 is having 2 is having neutral charge. 2 is having neutral charge. Clear? This is neutral, right? Now here it is having the charge. Done? Now next, fourth example, if you see. Now in the fourth example, if you take this carbocation, now here oxygen, it is having the lone pair of electron. Now for the another one, now here the oxygen, it is bearing the positive. Among those two, which is a more stable resonating structure, 1 and 2. Among the 1 and 2, 2 is the more stable resonating structure. Why is the 2 is a more stable resonating structure? Because now you can see oxygen octet completed. 1, 2, 3, 4, 5, 6, 7, 8. And more the number of pi bonds it should be there, right? Now more the number of pi bonds. Here there is no pi bond. Here the pi bond it is there. Clear? That's the reason more pi bonds. Reason more the pi bonds. Clear? More the number of pi bonds. Done? Now next if suppose question 1 they have given this one 1. Now 2 they have given 1 resonating structure they have given. Clear? 1 2 1 resonating structure they have given, and the 3 they have given. Now 1 resonating structure they have given in this manner. Clear? 1 resonating structure they have given in this manner. Clear? And the another resonating structure they have given. Oxygen bearing the positive charge, carbon bearing the negative charge, oxygen, nitrogen, and this is a hydrogen. Clear? Now we have to say the stability order. First one is a more stable because neutral. Clear? Neutral. Then after that, after the neutral, next we are going to see the second one, pi bond, due to the pi bond. Clear? Now third, a more electronegative atom bearing the negative charge and opposite charges are nearer. Here also opposite charges are nearer, but more electronegative atom bearing the negative charge is more stable than the less electronegative atom, right? So 3 and 4. Now this is a stability order. Clear? Now we have studied about the which one? What is the resonance? Now here we are going to see the next one. What is mesomeric effect? Up to now we have studied about the resonance, right? Resonance and the mesomeric effect both are same only. Both will what? Both will give the stability to the conjugative system. Sir, what is the meaning of the conjugative system? Now I will explain very clearly. Now listen. What mesomeric effect or resonance effect or next one we are having the conjugative effect. So what is the mesomeric effect, what is the resonance effect, and what is the conjugative effect? Now we see. Before going to that one, I will explain what is the meaning of the conjugative. Clear? And what is the meaning of the conjugative effect? Conjugative effect means here if the carbon double bond carbon and one single bond and we are having the double bond. Clear? This type of the system we call it as a conjugative system. Clear? This type of the system we call it as a conjugative system. Done? Now in this manner, double bond, single bond and the double bond and the single bond and the double bond, this type of the system we call it as a conjugative system. Sir, can you give any example? Now you can see here R C double bond OH. Clear? Now you can see here the carbon alkali single bond and C double bond O. In this manner, this type of the conjugations we call it as a which one? Conjugative system. Now with this only we are having the another type of the conjugation. What is that? Here that is we call it as a cumulative, or that we call it as a cumulative diene. Cumulative diene means what? This is a cumulative diene. Clear? Next, another type of the diene we are having, that is isolated diene. That is a isolated diene. Now isolated diene means double bond, single bond, single bond and the double bond. Cumulative diene means continuous, and the conjugative diene means one double bond, one single bond, one double bond and the one single bond. Clear? Now this one we call it as a, which one? Isolated diene. Clear? Isolated diene. Done. Now here any compound to show the mesomeric effect. Any compound to show the mesomeric effect. Now what are the conditions it should have? Clear? Any compound to show the mesomeric effect. First, what is the meaning of the mesomeric effect? Now first, in the mesomeric effect, it is having displacement of, in the mesomeric effect, the first key point we have to remember that displacement of the complete pi electrons. Displacement of the complete pi electrons is known as mesomeric effect. Mesomeric effect. Clear? This is the first key point you have to remember any compound to show the mesomeric effect. Clear? And the second point, displacement of the complete pi effect. Second, now sp3 carbon atom, if it is present in that compound, does not show mesomeric effect. If any sp3 carbon atom, if it is present in the which one atom, it does not show the mesomeric effect. Why it does not show the mesomeric effect? Because, clear? Now because here sp3 carbon, what is the hybridization of the sp3 carbon? Tetrahedral, right? Means delocalization or mesomeric effect. Delocalization means transfer of the pi electrons only, right? Delocalization to show all the atoms should be in plane, should be in the plane. Clear? Now plane in the sense, what is the meaning of the plane? Means all the atoms should be in the, all the atoms should be in the sp2 hybridized. All the atoms must be sp2 hybridized. Delocalization does not takes place in non-polar molecule. In the non-polar molecule, it does not takes place. Clear? Delocalization does not take place in the non-polar molecule. Sir, why it will not take place in the non-polar molecule? With the help of molecular models, I will explain very clearly. Okay? Now, next point. The next point you have to remember that now delocalization will be more effective in 2p and 2p orbitals. In the 2p orbitals, it will be more effective. Why it will be more effective? Means this 2p and 2p orbitals, this 2p and the 2p orbitals are parallel to each other. These two are the parallel to each other. These 2p orbitals are parallel to each other. That's the reason delocalization will be more effective. See now how the delocalization is more effective in this 2p orbitals. I was with the molecular models. I will explain very clearly. Clear? Now we'll see the how the mesomeric effect has been divided. Now the mesomeric effect has been divided into, again it has been divided into two types. In the inductive effect we have seen, right? What? how the plus I groups and the minus I groups. In the same way, mesomeric effect also, it has been divided into two types. One is the plus M groups and the minus M groups. That mesomeric effect, again in the inductive effect we have seen, right? Here also in the mesomeric effect also we are having plus M groups and we are having the minus M groups. Okay. Now how to identify the plus M groups and how to identify the minus M groups? So what is the meaning of the plus M groups, sir? Plus M groups means electron releasing groups. Electron releasing groups or electron repelling groups. Clear? Now these are the electron withdrawing groups or electron attracting groups. Electron withdrawn groups. Clear? Done. Now for the any given species, how to identify the plus M group, how to identify the minus M group? If the given species is a plus M or if the given species is a minus M, only one key point that if you remember, this is enough to identify whether the given species is a plus M or minus M. Clear? Now if any lone pair containing species, if any lone pair containing species, if it is directly attached, to sp2 carbon, those groups are plus M. Those groups are plus M. Clear? Now here what is the meaning of the minus M? If lone pair absent species, directly attached to sp2 carbon, those groups are called as a minus M. Those groups we call it as a minus M. Done? Clear? Now what are those groups? Now we'll see. Clear? Now first plus M groups. First is the plus M groups, we'll see. What are the, which groups will comes under the plus M? First O minus. Clear? Next OH and NH2. Clear? Next NH C double bond O R. Clear? Next NH R. Clear? Now secondary amine. Clear? Now next R2. Done. Next O double bond C O R. Clear? Next halogens. Clear? Next S H etc. Now these are the plus M groups. These are the plus M groups because all are containing lone pair of electrons. Done. Now if minus M groups, what are the minus M groups? What are the minus M groups? Minus M groups are lone pair absent species. Now aldehyde, here the carbon does not contain any lone pair. Done. Next is a ketone. Ketone also does not contain any lone pair. Clear? Now this is benzoic acid. Sorry, not this is carboxylic acid. For the carboxylic acid also carbon does not contain any lone pair of electrons. Done. Now sulfonic acid. In this sulfonic acid also sulfur does not contain any lone pair of electrons. How the sulfonic acid will be there? Now double bond O and O, and this is a H. Clear? Done. Next one will be the acid amide. Now this is the acid amide. For this acid amide also carbonyl carbon does not contain lone pair of electron. And next will be the acid chloride. Then next one will be the cyanide. Clear? Done. Next one will be the nitro, NO2. For this nitro also there will be no lone pair of electron on the nitrogen. Now nitrogen, this is a double bond O and this is a coordinate covalent bond with the NO2. Clear? All the electrons has been involved in the bond. Then nitrogen does not contain any lone pair of electron in the NO2. Next CX3. CX3. Next NH3 plus, NH3 plus, clear, and NF3, etc. Now these are the groups which will withdraw the electrons, and these are the groups which will release the electrons, clear. Now here, now based on this one, now we are going to see the which one, now types of resonance. Now how many types of the resonance we are having, how this resonance will be shown, clear. Now the first one we are having types of resonance, Now in the types of resonance, first one we are having what, pi conjugation. First one we are having the pi conjugation. Done. Now what is the meaning of the pi conjugation? Means already I explained you. Carbon double bond, carbon single bond, and double bond. Double bond carbon and one single bond, and one double bond and the single bond. That type of the contribution we call it as a conjugation, pi conjugation. Clear. Now second one we are having the pi and carbocation, conjugation, and third we are having the pi and carbanion conjugation, clear. And the fourth we are having the pi and free radical conjugation. Now fifth we are having the pi and lone pair conjugation. Done. Now sixth we are having the cation and lone pair conjugation, and the seventh one we are having the vacant d orbital conjugation. Now this many types of the conjugations we are going to see. Now the first type of the conjugation that we are going to see, which one? First one is a pi and pi conjugation. In this pi and the pi conjugation, first one, this is a carbon, this is a hydrogen, and this is a hydrogen, and this is a carbon, and this is a hydrogen, and this is a carbon, and this is a hydrogen, and this is a carbon, and this is a hydrogen, and this is a hydrogen. Done. See, these all the bonds are hybridized orbitals, and those all are the sigma bonds. Now here in the C1 carbon and the C2 carbon, whatever the pi bond it has formed, that pi bond is formed due to the pure p orbital, right? Already I explained you, because this carbon hybridization is sp2, this carbon hybridization is sp2, this carbon hybridization is sp2, this carbon hybridization is sp2. Now here also whatever the pi bond it has been formed, that pi bond is formed due to the pure p orbital, right? Whatever the pi bond it has formed, that pi bond is formed due to the pure p orbitals. Clear? Now what is the one key point I said? Now any compound to show the delocalization, first all the carbon atoms should be in the same plane, See, now this is a carbon atom, all are sp2, all the carbon atoms are sp2. When all the carbon atoms are sp2, and these pi electrons are parallel to each other or perpendicular to each other? These pi electrons are parallel to each other, they are not perpendicular to each other. When these pi electrons are parallel to each other, now this delocalization will be happen. Now how the delocalization will be happen? Now this electron will be moved to this orbital, and this electron will be moved to this orbital. Clear? Now when this electron has been moved to this orbital, and when this electron has been moved to this orbital, now how the delocalization we will show? Now based on that one only, now I was writing this one. Done. Now in this manner the delocalization will be happen. Now this electron will be moved here, and this pi electron will be moved to this carbon. Then what it will happen? Now based on that, here one positive charge, here one will be the negative charge, and here it will be the positive charge. Here in this manner the resonance will be happen. Done. Now if you take, if you want to see in the which one, in the form of orbital diagram, in the form of the orbital diagram, in the form of the orbital diagram, if you see clear, this is the in the form of the orbital diagram, in the form of the orbital diagram. Now when it has resonance has been happened, when the resonance has happened, now this orbital will have the positive charge, clear. Now here whatever the pi bond it has been formed between, it will be the bond. Now here it will be having the negative charge, clear. In this manner the resonance will be happened, in this manner the resonance will be happened. Now we'll see with the molecular model. Now with the help of the molecular model, now in the how the pi and the pi conjugation it is showing the delocalization. Now we'll see. Now in the pi conjugation, already I said you, this carbon is sp2, this carbon is sp2, this carbon is sp2, and this carbon is sp2. All the carbons are sp2. In all the carbons, if it is sp2 and their 2p and 2p orbital should be parallel to each other, right? Now you see, this is a pure 2p orbital of this carbon. This pi bond will be formed by the which one? Sideways overlap, right? Clear. Now this is a one 2p orbital of this carbon, clear. Now you can see both are the which one? Parallel to each other or perpendicular to each other. Now these pi bonds are both are parallel to each other, means these 2p orbitals when they have overlapped, those 2p orbitals will be parallel to each other. In this manner they are parallel to each other, clear. When these are parallel to each other, now this pi bond if it is delocalized, now if this pi bond if it is delocalized in this manner, now you can see here this carbon it got the positive charge, and the middle carbon we got the carbon and the double bond, and this carbon it got the one negative charge, clear. In this manner the delocalization will be happened in the pi and the pi conjugation, clear. Now clear. Now if the conjugated diene if they are given, now the resonance is happening, clear. Now this pi electron is moving from the, now where here one in between this C1 carbon, C2 carbon, C3 carbon and the C4 carbon. Now this is known as the pi and pi conjugation. Now next, if suppose cumulative diene if they have given, if they have given the cumulative diene, what is the meaning of the cumulative diene? Here the carbon and hydrogen, here the carbon and hydrogen, here the double bond, here the carbon and here the double bond, and here if it's the hydrogen if they have given. If this type of the cumulative diene they have given. Now in this cumulative diene, now here what it will happen? Resonance will not show. Done. Sir, why the resonance will not shown? What I said? Now each carbon should be the sp2 and all the atoms should be in the plane. Now this pi bond and this pi bond, if these two are the parallel to each other, then it will show the resonance. But in the this cumulative diene, now you see now how the cumulative diene, now these pi bonds are there. In the cumulative diene, now this is a cumulative diene. Now you can see this is a carbon, two hydrogens, now one pi bond and one sigma bond, and the middle carbon and one sigma bond and one pi bond, and this is a carbon. Now you see this is a pi bond and this is a pi bond. Now these two pi bonds are parallel to each other or perpendicular to each other? It is perpendicular to each other. Now what I said, if the two pi bonds are parallel to each other, then only the delocalization will be happened. But here you can see, here one is in this manner and one is here. These two are the perpendicular to each other, right? When these two are the perpendicular to each other, how it will show the delocalization? So that's the reason in the alene molecule there is no any delocalization is possible. Clear? Done? No. In the alene molecule there is no any delocalization if the what even number of cumulative diene if they have given, there is no any delocalization is possible. Clear? Now next let's suppose, and now if the even number of the cumulative dienes if they have given, resonance is not possible. Next, if suppose one molecule, if they are given in this manner, CH2 double bond C double bond O, if suppose if they are given, in this case here also the cumulative diene we are having, right? Clear? Here also we are having the cumulative diene. Now if suppose if this compound they have given, now here the delocalization is possible. Sir, how come, sir? Just now you have said that even number of the cumulative diene if it is present, it is resonance is absent. Then here also even number of the cumulative diene it is present. Then how we are saying that resonance is absent? My dear friends, now wait, I will explain. Clear? Now when this molecule has been resonated, now this carbon will get the CH2. Clear? Now here it will get the oxygen, it will get the positive charge, because now you can see, now this oxygen octet has been completed, right? Octet has been completed. Now this is a more resonating or more stable resonating form, right? More stable resonating form. Stable form, right? Because more octet completed and the opposite charges are near. Now, sir, how come this resonance is happening, sir? Now, can you explain with the molecular model? Yes, I will explain with the molecular model. Now, listen. Now, this is a molecular model of the which one? Now, C double bond O. Now, here you see what I said. Any resonance to be happen, double bond should be parallel to each other, or lone pair and double bond should be parallel to each other. Now in this molecule you see, this is oxygen, it contains two lone pair of electron. Now in this oxygen two lone pair of electron, one lone pair of electron is parallel to this bond, right? This oxygen lone pair of electron is parallel to which one? This bond, you can see. This oxygen lone pair of electron and this carbon pi bond is parallel to each other. That's the reason this oxygen has been delocalized here and this pi bond has been shifted towards this carbon. In this manner the delocalization has been happened. Clear? And it is giving the stable resonating structure. Stable resonating structure. Clear? Done? Now, only if the even number of the cumulative diene if it is present with the oxygen and its lone pair, then it is present. Then it is what? Delocalization is present. But if all are the carbons, even number of the cumulative dienes with the carbons if it is given, there is no any resonance will be happened. There is no any resonance will be happened. Clear? Now, next, second type of the resonance we are seeing, pi and cation resonance. Pi and the cation resonance. Now, how the pi and the cation resonance will be happen? Now you see. Now, pi electrons and carbon 2p orbitals should be parallel to each other. Should be parallel to each other. Should be the parallel to each other. Now, how they are parallel to each other? Now we'll see. Clear? Here, if I was taking this one carbon CH2 and here the one sigma bond carbon and here it is the one sigma bond carbon and it is having the two hydrogens. Whatever the carbon it is having the positive charge. Now that positive charge p orbitals will be perpendicular to this which one? Sigma bonds. Now whatever the pi bond it has formed for this carbon, now this pi bond and this empty p orbital is parallel to each other or perpendicular to each other? Now parallel to each other. Now in this manner they are parallel to each other. Now they will resonate in this manner. Now this pi bond will be shifted here. When this pi bond has been shifted here, now this carbon it will get the positive charge and this carbon will form the pi bond in this manner. It will be resonate. Clear? Now with the help of the molecular model, now we will see. Now with the molecular model, now will we see. Now in this molecular model, we are having this carbon and two hydrogens, one pi bond and one sigma bond. You can see carbon, two hydrogens, one pi bond and one sigma bond. Clear? And this carbon and this is a sigma, and this carbon and this is a sigma. Clear? And this carbon it is having the hydrogen. You can see this hydrogen. Now this carbon, it is having the vacant p orbital. This is a vacant p orbital and these two are the hydrogens. Now you see this pi bond, this carbon and carbon pi bond, and this carbon vacant p orbital. In the carbocation, this vacant p orbital. Both two are the parallel to each other, right? See, with the molecular model, you may having thinking that, sir, here this is in this manner and this is the pi bond is in this manner. So how these two are the parallels are, this is perpendicular. Now with the sideways overlapping only, leads to give the pi bond, right? Now you see, this is one empty p orbital of the sp2 carbon. Now this is a one empty p orbital of the sp2 carbon. Now you see both are parallel to each other only, right? Now these two sideways overlaps. Here also one, which one? Empty p orbital will be there. These two sideways overlaps leads to give this pi bond only. Means this pi bond will be always perpendicular to the sigma bond. Means these two are parallel to each other. They are not perpendicular to each other. Clear? That's the reason it will show the delocalization. Done? Clear? Now we'll see some examples of the pi and the cation delocalization. Pi and the cation delocalization in the benzene also. If you take the benzene, now for this benzene also, this will play very crucial role in the benzene. Now for the benzyl carbocation, this empty p orbital and this benzene pi electrons are not perpendicular to each other, they are parallel to each other. Sir, how they are perpendicular to each other, sir? Now with the help of molecular model, I will explain. Now listen. How you see. Clear? Here this is a benzene. Clear? Now this is a benzene. Now for this benzene, one now here for this benzene, what I was added? Now this is a CH2 and one, this is a, you can see this is a benzene. For this benzene, now this is a carbon and these two are the hydrogens and one this empty p orbital. Now for this carbon, for this benzene, this carbon and this carbon, this is a pi bond, right? Now this pi bond and this empty p orbital is not perpendicular to each other, they are parallel to each other. How? Now you see, here this carbon pure p orbital, this carbon pure p orbital and this carbon pure p orbital only sideways overlaps leads to give this pi. Now you see, this carbon pure p orbital or whatever the pure p orbital it is having, and this carbon pi bond or pi bond means formed by the pure p orbital, right? These two pure p orbital are parallel to each other or perpendicular to each other. They are not perpendicular to each other, they are parallel to each other. In this manner you can see. In this manner, these two are the which one? Parallel to each other. When these two are the parallel to each other, then benzene, by that we got to know that this benzene pi electron and this carbocation empty p orbital both are parallel to each other, means it will show the resonance to this carbocation. Resonance means this pi bond or this pi bonded electrons will be shifted towards this which one? sp2 hybridized carbon, so that this benzene will show the delocalization to this carbocation. Done? Clear? Next, some other examples. Now we'll see. If suppose if they have given CH2 double bond CH and CH2 plus, if they have given, now the delocalization will be happen. Now this pi electron will be delocalized here. Now we'll get the CH2 plus. Now here the C double bond, here the H, and here it will get the CH2. In this manner the delocalization will be happen. Let's suppose if they have given in this manner CH2 double bond CH and NH3 plus, if they have given NH3 plus they have given. Now if suppose if they have given, you may think that this pi electron will be moved to this NH3 plus, but here the delocalization will not be happen. Sir, why, sir? Now already I explained, delocalization to be happen, all the atoms must be sp2 hybridized, but this atom is sp3 hybridized, right? Now you can see one sigma bond and the three hydrogens. Already I explained. If the hydrogen present, blindly believe that is a sigma bond only. Blindly believe. Here one hydrogen. Here how many hydrogen? Three hydrogens and one sigma bond. Hybridization number is 4 or steric number is 4. Means that it will give you the sp3. sp3, any sp3 atom if it is present, there is no any delocalization. Clear? Now here the delocalization will not be happen. Done. Next. next type of the delocalization that we are going to see. Next, third, pi and anion conjugation. Pi and the anion conjugation. In this pi and the anion conjugation, now we'll see here the both the pi electrons and anion negative charged electrons. Anion negative charged electrons are parallel to each other. That's the reason only delocalization is happening. Parallel to each other. See how they are parallel to each other. Now we'll see. Here this is the CH2 double bond CH, and here the CH2, and it is having the negative charge. Now this negative charge will be delocalized here, and this pi bond will be shifted towards this carbon. Then what will happen? Now this pi bond will get the negative charge, and this carbon will get the double bond, and it will get the CH2, and it will get the CH2. In this manner, now pi and anion conjugation will be happen. Now with the molecular model, now we'll see. Now, in this molecular model, here now you can see here this is a carbon, two hydrogens, one sigma, one pi, and this carbon and sigma bond, and this carbon it is having the two hydrogens and lone pair, right? Now you see this lone pair carbon, this lone pair, and this pi bond is both are parallel to each other. Sir, how these two are the parallel to each other? Now we know sideways overlapping of the pure p orbital only leads to give the pi bond. Now you see this carbon pi bond, or this carbon empty p orbital, and this carbon lone pair of electron, both are parallel to each other, right? You can see in this manner parallel to each other. Means this sideways overlap leads to give only the which one? Pi bond. Means this pi electrons and this carbon negative charge are not perpendicular to each other, they are parallel to each other. Clear? Done? Now next we will see the fourth type of the conjugation, that is pi and the free radical conjugation. Pi and the free radical conjugation. In the pi and the free radical conjugation, now this is a pi bond and one the free radical. We have seen. Now how the free radicals will form? Already I explained. Free radicals will be formed by the what? Homolytical breakage, right? When the homolytically when it has broken, now this carbon pi bond contain the two electrons, right? Now that carbon, that pi bond which has been formed here, now that it has been shifted towards the one carbon. Now it has been shifted towards this carbon. Clear? Now this radical we are having already. Now this radical and this radical will form the bond. This radical and this radical will form the bond, and it will give you the here the radical, here the hydrogen, here the hydrogen. Now here the carbon, double bond, here the hydrogen, and here it is a CH2. Now this is a resonating structure of the pi and the free radical. Pi and the free radical resonance. Clear? Done? Now next, fifth type of the, which one? Fifth type, we are having that pi and lone pair. Pi and the lone pair conjugation. Pi and the lone pair conjugation. Pi and the lone pair conjugation and the pi and the anion. Here we have seen, right? Pi and the anion and the pi and the lone pair. Lone pair negative charge and the lone pair is almost same. Clear? That lone pair also contain two electrons. Negative charge also contain the two electrons. Done? Here how it will be happen? CH2 double bond CH, and here the CH what? CHRRLs. Here we can see chlorine. It is having the lone pair of electrons. Now this chlorine lone pair of electrons will be delocalized, and this pi bond will be shifted toward this carbon. Now how it will show? Here the CH2 minus, and here the CH double bond Cl, and it is having the positive charge. But even though it is having the positive charge, this octet is completed. This octet is completed, and this is a stable, and this is a stable. Done? Now if suppose here already we have seen CH2 double bond CH and if suppose NH2 if they have given. Now this nitrogen lone pair of electrons will be delocalized and the pi bond will be shifted here. Now this is CH2 negative and here the CH double bond NH2 plus. If suppose if they have given CH2 minus and the fluorine, and here the CH2 minus and the chlorine. If suppose if they have given among the 1 and 2, which one will show the delocalization and which will show the delocalization? Now we'll see. Here the CH2 negative and the F they have given. Here the CH2 negative and the chlorine they have given. Now one will not show the delocalization and this one will be show the delocalization. Why? Because fluorine nucleus we are having the 1s2, 2s2 and the 2p5. There is no any empty orbital absent. Now for the chlorine case, 1s2, 2s2, 2p6, 3s2, 3p5 and 3d is having empty, right? Now due to the presence of this vacant d orbital, this negative charge will be delocalized to that chlorine vacant orbital. That's the reason in the CH2F delocalization will not be happen. Now in the chlorine case, delocalization will be happen due to the presence of which one? Empty d orbital. Clear? Now due to the presence of that empty d orbital, it will show the resonance. Clear? Done? Now next. Now the next type of the conjugation that we are going to see for the benzene. Clear? For the benzene. Next. Already we have seen this vacant orbital. What? Conjugation. Now this is a which one? Now vacant orbital conjugation. This is a vacant orbital conjugation. Now we'll see cation and lone pair conjugation. Now in the cation and the lone pair conjugation, now if I take this oxygen, it is having the lone pair of electrons. Done. And it is having the carbocation. Now this carbon is a sp2. Now this vacant orbital and this lone pair of electron both are parallel to each other. Now this oxygen lone pair of electrons will stabilize this carbocation very fastly. So now here this oxygen, it will get stabilized in this manner. Clear? It will get stabilized in this manner. Let's suppose this cation and what? If suppose oxygen and this cation they have given. Now sulfur they have given. Sulfur also it will contain the 2 lone pair of electron and it is positive charge. Among those two, which one will be stabilized that carbocation very fastly? So 2 will stabilize the carbocation very fastly. Reason because this sulfur is a less electronegative and it will release the electrons very fastly. Sulfur is less electronegative and it will release this lone pair of electron very fastly and it will stabilize the carbocation very effectively. Clear? Now by this I was ending the class here itself, and the next we are going to see with the benzene, if the plus M groups and the minus M groups, if it is attached to the benzene, now how it will show or what it will happen to the benzene, now we are going to see in the next lecture.